All right, let's solve some problems from the test, Boyles Law and Charles Law. Now, there are 7 questions here. These may not be the exact 7 questions that you had on your version of the test because the test has a bank of about 20 questions that are selected. But the questions that you have, if they are not exactly like this, are very similar with probably just different numbers. Okay, let's solve these problems. The volume of a gas at 120 kilopascal is 200 milliliters. If the pressure of the gas is increased to 180 kilopascal, what is the new volume? All right, so let's list out what we know. You have to be careful here. Look at your units, make sure that they match. So for the volume, for V1, the volume is going to be 200 milliliters. The pressure, P1, is 120 kilopascals. And the new pressure is going to be 180 kilopascal. And you're looking for the new volume, okay? And you can see that right here. What is the new volume? Okay, so probably if you made a mistake on this one, it was by not putting the information in the correct place. And what I mean by that is you have to understand that milliliters is a volume unit and kilopascal is a pressure unit. So make sure that you're up on those units and what they represent. From there, we just need to write out the formula, which is going to be Boyle's Law. How do I know it's Boyle's Law? Because there's no temperature in here. Temperature would mean that you'd be using Charles' Law. So we've got P1 V1 is equal to P2 V2. Taking a look at this, you can see that the kilopascals are going to cancel out, and the only unit we're going to have left is milliliters, which is good because that's what we want for our answer. So knowing that, we can take a little shortcut here and we can just plug in the numbers and do the math a little bit more quickly. So what it would look like is this. P1 is 120, V1 is 200, and then P2 is 180, and you're solving for X, okay? So this simply becomes a matter of dividing and dividing, okay? That's canceled out. All right, and then when you do this math here, this should be fairly straightforward for you. This math right here is not something I would consider challenging for a high school student. Just remember to do the order of operations, which means to multiply 120 times 200 first, get an answer, and then divide that answer by 180, and what you should get is 133 milliliters. Okay, now how did I know that the unit was milliliters? Well, once again, if you go back and you look, if you have the same unit here and here for pressure, they're going to cancel out when you do the multiplication and division, and milliliters is the only unit left. Okay, it's a little bit of a shortcut, but we've solved problems with carrying units all the way through previously, and you should be able to go back to the videos that do that to watch that so that if you don't understand, you will. All right, let's go to number 2. Number 2 is a true-false question, and in order for it to be true, and the test states this, for this to be true, every part of the answer has to be true. So let's read it. The following units indicate a pressure measurement. I'm going to circle the ones that indicate pressure. Atmosphere is pressure. Kilopascal is pressure. Torr is pressure. Liters is volume. So this answer is, false. Okay. Remember, for it to be true, every part of it has to be true. There were a few students who got this one wrong, and I think that's because you went through it a little bit too quickly. Slow down on these true-false questions. They can be a little bit tricky. All right, let's go to the next one. Number 3. So a gas has a temperature of 100 degrees Celsius and a volume of 2.5 liters. You're going to heat the gas to 345. What's the new volume? So obviously this is going to be a Charles Law problem because it looks like you've got volume and temperature, okay, and you're looking to see what happens. So there it is. I had a student say, hey, Mr. Ashley, you didn't give us the formulas to use, so it's unfair. And my answer to that was this was an open book test. This was an open note test. This was an open YouTube test. This was an open Google test. You should have been able to use your resources to find those formulas. We used them multiple times during the week. So, all right, let's solve this. All right, so let's write down what we know from the problem. It has a temperature of 100, so that's T1 is equal to 100, and that's Celsius, so we're going to convert it instantly into Kelvin. Surprisingly, there were many students who did not change their temperatures to Kelvin. And that's where you made your mistake. Okay, so V1 is then going to be 2.50 liters. T2, okay, there's a new temperature, and that temperature is, that's a high temperature, 345 degrees Celsius plus 273. Just do the math right now and get your values so that you don't forget to change it to Kelvin. We're solving for V2. So once again, you can see that you've got Kelvin here and here. Those will cancel out in the math, and the only units left is liters, which is good because you want liters for your final answer. That's a volume unit. So let's plug in the numbers and solve, okay? So the way it's going to look is 2.50 over 373 is equal to x over 618. Okay, we've done many of these problems during the week. So basically what you're going to do is you're going to be multiplying those two together. So that's going to be 618 times 2.50. And you're going to be multiplying these two together and then dividing by 373, right, to get it away from the x. So there you've got a nice little easy algebra problem. This problem right here should be very easy for you to do at your level of math knowledge. And so when you do that problem, number 3, the answer that you get is 4.14 liters is equal to x. And that is the answer to the problem. So definitely go back and do the math on these things. Work them through, convince yourself that they are correct. And check back and see where you made your mistake if you did get that one wrong. Okay, number 4. Okay, number 4, same, we solve these the same way every time. They're never different, guys. What do we know? Well, we know that V1 is going to be 5.00 liters. We know that V2 is going to change. They're increasing the volume to 10.0 liters, okay? And then the pressure, the final pressure is given. Pressure is given as 7.00 atmospheres. And then they wanted to know, what did the pressure start at? Okay, so you got pressure and volume. Obviously, it's going to be a Boyles Law problem. So go ahead and put that down. And then once again, guys, same thing again. Plug in the numbers, okay? There's never any curveball on these things. And I'm using a bit of a shortcut on this. You notice that I'm not putting the units down. And that's because if you look at the units, you can see that some of them will cancel out in the math, right? What I mean by that is liters is going to cancel out with liters. And what's the only unit you're going to have left? Atmospheres, which is good because we're solving for pressure, and pressure is measured in atmospheres. So here we go. Let's do the problem. We're going to divide by 5.00. We're going to divide by 5.00. So x is equal to, and once again, guys, I keep saying it, but like this kind of math problem right here is literally a 7th or 8th grade math problem. You should be able to do that by now. And we've done many of these previously, so I'm not going to take the time to do that math. I'll just give you the answer and you can check your work. So for number 4, that's going to be 14, and the unit will be atmospheres. Now, you could solve this problem intuitively by what you know about the Boyles Law, because what's happened here is that the volume has increased. So what happens is if you increase the volume, you oh, wait a minute here. We went from 5 liters to 10 liters, and from 7 atmosphere to 14, back to 14. I'm sorry, guys. So Yeah, we increased the volume, and so that means that we would have had to have decreased the pressure. And so it went from 14 to 7. It was cut in half. All right. That's because Boyle's Law, if you remember, is an inverse. Oh, that's not what I want. Is an inverse relationship. Here we go. It's an inverse relationship, right? And you started at 5 and you increased it to 10. And so it ended at 7. So the pressure had to have been double that, which is 14. Okay, so that takes care of number 4. The way we solve these is always the same. Let's go on to number 5. Okay, first of all, we're just going to do the same thing we've done before. We're going to write down what we know. And in this problem, we know that the starting pressure, P1, is 4.50 atmospheres. Okay, and the starting volume is 1.90 liters. Okay, and then the ending pressure is 6.70 atmospheres, and the ending volume is going to be, who knows what it's going to be, right? But we can calculate it because, once again, this is another Boyle's Law problem. You guys kind of lucked out. Boyle's Law is an easy one. So let's plug in the numbers for Boyle's Law here. And so first of all, we know that atmospheres is going to cancel with atmospheres, leaving us with liters, which is good because that's what volume is measured in for number 5. So we've got, let's just put in the numbers, keep it nice and clean. 4.50 times 1.90 is equal to 6.70 times x. There we go. So once again, it's going to end up looking like this. 4.50 times 1.90 divided by 6.70. Okay, so there you go. You got your pretty simple problem here again and again and again. It's the same thing. And so what's the answer to number 5? Well, x comes out to be 1.28 liters. There it is. All right. And you guys, you can see that when I solve these problems, I do the same thing every time. First, I write down what I know. Second, I write down the formula. Third, I plug in the values. Okay? Are you doing the same thing? Look at your work. Compare yours to mine. Yours should look like mine. If you find that you're not doing it the way that I've taught you, which is to write down what you know, write down the formula, then plug it in and solve it, then you're kind of just, you're going off into your own style of solving things, and that can become a problem. All right, let's go to number 6. Okay, so in 6, I see that we have a starting volume, V1, of 6.80 liters, and we have an ending volume of 0.900 liters, and we have an ending temperature of 5 degrees Celsius, which we will immediately change into Kelvin. Okay, there it is, 278 Kelvin. And they want to know what was the starting temperature. So that's what you're solving for. So this is a Charles Law problem. Here we go. V1 over T1 is equal to V2 over T2. Let's look at the units. Liters is going to cancel with liters, leaving us with Kelvin, which is good because we have a temperature that we're solving for, and it will be in Kelvin. So let's plug in the numbers, and then we can solve this problem. So what we're going to have is 6.80 over x equals 0.900 over 278. Okay, so you're going to cross multiply those two. So you're going to get 6.80 times 278 is equal to, and then you're going to cross multiply these two, which is 0.900 times x, and then to get x, you're just going to divide that by 0.900. So there you go. Here's the problem that you have to be able to solve. Can you do it? Of course you can. And so what you get for your answer for that is that x comes out to be 2,100. Now, what is the unit? Okay, well, remember, we have Kelvin. So the unit is Kelvin. It, of course, would not be Celsius because we've already converted from Celsius to Kelvin. Okay, all right, so there's your answer for number 6, 2,100 Kelvin. Okay, all right, finally, last one. So this was just a multiple choice answer. So let's read it through. You have a 3-liter sample of gas and you put it in a refrigerator. So that means you cool it down, right? It went from, it started at 10 and it went to 5. So you reduced its temperature by half. So we know that this is a Charles Law problem, right? Because you're looking at temperature and volume. And if you cut the temperature in half, you should decrease the volume by half. So your answer would probably be something like the volume would be less than 3 liters. And if you were really fancy, you would say it would be half of 3 liters. It would be decreased by half because according to Charles' law, which says that temperature and volume are directly proportional, if you cut one in half, you cut the other one in half. All right, so that's a run through of a version of the test. But like I said, the other problems are very, very similar. You notice that in this problem, I'm seeing 1 Charles Law problem, let's see, 2 Charles Law problems, and 3, it looks like 3 Boyles Law problems. So, there are many places you could have made small mistakes. The number 1 place would have been not to change temperature to Kelvin. And then the second most common one is just not understanding how to do this basic type of math problem right here that comes up in every problem. It's a thing that we've worked out. I mean, we've done these problems in class, and we've done the calculator work. But if you didn't do the calculator work, if instead of taking the time to actually push the buttons with your own fingers, you got the answers for the homework from your friend, or you just copied them from the videos, and you never really took the time to do the homework on your own, you'll get a great homework grade, but of course you won't know how to do it on the test. And so I would say for the next test, just ask questions. And if you can't solve a problem, stick around when everybody else leaves to go asynchronous, and let's do some one-on-one tutoring. Okay, guys, there's the test, and please check it over and compare to your work.